Okay, I think I will start the screen sharing, and Imre, let me know when we will start and I can step the first slides for you.
Perfect. We are live now. Feel free to get started.
Okay, thank you so much. So, welcome everybody. This meetup will be about introducing Hypernate, our new data mapper framework for Hyperledger Fabric Chaincode. This just became a Hyperledger Labs project. We are from the Critical Systems Research Group at the Budapest University of Technology and Economics in Hungary. And we do ask you if you have any questions, then please post those in the chat, and hopefully we will have the chance to do a small Q&A at the end of the 1 long hour meetup. Now, speaking today will be Attila Klenik, a colleague of ours who did his PhD with us at the Critical Systems Research Group and who is still with us as a research fellow, but is also at the same time a senior DLT architect at our National Tax and Customs Administration. He's also one of the maintainers of Hyperledger Caliper. We also have Bertalan Zoltán Péter, a PhD student of mine, and I'm Imre Kocsis, an associate professor with the Budapest University of Technology and Economics, and the blockchain lab lead here. Next, please. Now, the blockchain lab started with Hyperledger Fabric performance analysis back in 2016, when Fabric was still in its 0.3, 0.4 version series. That was quite an interesting start time. We began with it and stick around for that. The mission statement of the lab is that we are creating and applying systems engineering tools and methods for critical DLTs, distributed ledgers. In LFDT, formerly Hyperledger, we were active in the performance at scale working group, and as already mentioned, Attila is a Caliper maintainer, and now we have this lab project that we will talk about today. Out of our numerous industrial and R&D activities, we are probably the most proud of the central bank digital currency stream of research that we did with our central bank here in Hungary. That ended last year, but since 2023, we have been having a quite intensive and very nice Hyperledger Fabric targeting research and development cooperation with the National Tax and Administration, who are creating a Fabric-based project called ePayroll. We are engineers, so we do apply theory and we do dabble in applications and know the platforms, but we are probably the most happy when we can work on the things that you see in blue on the right side. And with that opening, I would like to give the floor over to Attila, who was the key architect of the project that matured into becoming a Labs 1. Attila, please.
Thank you, Imre. As Imre mentioned, we've accumulated quite an extensive experience when it comes to developing chain codes throughout our various R&D project or even education specific, let's say, homegrown projects. And during these activities, we also accumulated a few headaches along the way, and we tried to address as best as we can these headaches with Hypernate. So first of all, we hope that Hypernate will achieve at least the following. So it will lower the entry barrier for newcomer developers, which is especially important when we are teaching students who never learned about Hyperledger Fabric before, but it's also a critical path toward the rapid application development and prototyping of DLT systems. We found a lot of confusion regarding the intentions of developers when using Fabric APA, and we had to chase obscure bugs related to such. What were the developers thinking? Kind of train of thoughts. And of course, since the Fabric API is quite low level in the chain code, the testing became also a bit of an error-prone, tedious process. So we took all of this experience and created Hypernate from it. But what exactly is Hypernate? In its simplest form, Hypernate is a library on top of the familiar contract programming API of Fabric Chaincodes, specifically in Java. So we try to get away from the key value level API as much as possible and introduce some object-oriented, higher-level abstraction design to enforce good practices and robust chain code development. What Hypernate isn't yet, even though its name might suggest some resemblance to similar tooling, it's not a full-fledged object relational mapping framework yet, so there is no hidden byte emission, code generation magic going on behind the scene. We are not managing entire object graphs and navigating these graphs in a smarter way. So as you will see, Hypernate starts small, target specific pain points, and who knows where we will end up with this library. So what is exactly Hypernate in a technical sense? Hypernate is a library that sits completely on top of the old school Java Chaincode SDK. And this means that it's an extension of that library, and thus it is, let's say, hybrid compatible. So you can use Hypernate at certain parts of your Chaincode, but you can also use the old school SDK as well. So we will give you an extended contract implementation, context implementation, and some specially crafted Chaincode stub middleware platform. What exactly is that? You will see soon. So we will try to leave behind the previous word you can see on the right side, where we mix and match storage logic and object creation, serialization, and key creation with traditional business logic, and this becomes easily repetitive and error prone. Instead, Hypernate will give you some declarative way to manage your asset keys and higher level object oriented create, read, update, delete operations with some nice semantics, as you will see. And of course, we will introduce some methods to keep your non-business related technical boilerplate stuff separately from your critical code of paths. So what do I mean by declarative asset keys? Instead of coding the serialization logic into the place where you want to when you want to persist your asset, instead you will declaratively annotate your asset classes with these key information, like which attributes constitutes the key of this asset, and it will become configurable of how we want to serialize this. And at the place of creation or ledger interaction, you just say that, please create this asset for me. And everything else will be handled by you. No need to create your composite key manually, and so on and so on. So Hypernate extracts these orthogonal aspect of storage management more or less next to your business class and not intertangled with it. So it's a loosely coupled and flexible solution. When I say that we bring object-oriented operations to you, we are not just talking about, okay, let's handle objects instead of strings and bytes. We also introduce some nice explicit API semantics into the components that handle such ledger interactions. You can see some basic example here from the library itself. For example, when creating a new asset, we have explicit semantics for what should happen during this call. So it's no longer a guesswork from developer side. If I read that something must be created, and this call succeeds, it means that this asset did not exist before, and now it will be returned to the ledger. If I'm saying that, okay, I don't want to be this strict, let's try to create something, then I will get in return a value indicating true or false, whether the creation was successful or not. So now you can make your intent explicit with this API. You will see this in work in Bertalan's demonstration. And perhaps one of the most interesting parts of Hypernate is what we call a middleware chain, or you can think of it as a pipeline of Chaincode stubs. So the Chaincode stubs, as you can see at the bottom of this right side figure, is what you so far used to interact with the ledger. It has the put operation, the get operations, the queries, and so on. Why would we like to change this? Mainly because some tasks are not related to your core business logic, and you don't want to litter these all around your codes in an ad hoc manner. And more importantly, as it were with us, we want to reuse these solutions across multiple projects. And sometimes you need some features, sometimes you don't need some features. So we created a middleware chain that can sit between your object-oriented API and between the original Chaincode stub. And in between, as you will see, you can essentially change the behavior of how you interact with the ledger, and that will remain nicely decoupled from rest of your code. And at this point, I will pass the screen sharing to Bertalan, who will now give a real-life demonstration about all these features that I just mentioned.
Okay, thank you, Attila. Let me just share my screen then. Could you please confirm if you can see it?
Yes, we can see it.
Okay, thanks. So let's begin. The plan for today is that we are going to, I will be demonstrating Hypernate in a hands-on demo to you by refactoring an existing Chaincode sample. All of the stuff that I will be showing you can find in the Hypernate samples repo on GitHub. It's also part of the LFDT Labs namespace. And there is a demo branch with today's date where all of these commits that you can see here are what I'm going to be doing essentially. So if you want to follow along or you want to look at it later, you can go step by step through these commits and see what has changed and try it for yourself. But for now, I am just going to check out the initial state here where, so just let me just get zoom out of the way, where I have the asset transfer Chaincode sample in its original form. Some of you may be familiar with this. It's a classic sample project in the Fabric samples repo. For those of you who are not, it essentially has just a simple asset class, which is identified by a string asset ID identifier, and it has a few other properties and the usual boilerplate stuff here, getters, setters, constructors, and so on. And the contract basically gives CRUD operations with these assets. So there is an initialization transaction where a bunch of new assets are created, and there is create, update, read, delete, and there is an additional update-like transaction in the original code that updates it in a specific way. It updates an asset's owner, essentially transferring it to somebody else. There are a few minor changes in the version we are working with compared to the one that is in Fabric samples, but nothing major. And by the way, immediately looking at this code, we see some of those annoying things that Attila was showing on his slides. For example, all of this error handling code that is repeated and all over the place, the creation of composite keys in an ad hoc manner, dealing with all the composite key creation, the serialization to JSON, and then the JSON serialization into bytes, or byte arrays, I should say, and so on. We can already see that the developer of this sample has already started to factor out some of the common logic, which is already going in the direction of what Hypernate does, just I suppose on steroids. For example, there is this put asset utility function that is used everywhere within the Chaincode, within the contract to take care of updating stuff on the ledger, or updating an asset. And there is also the additional logic of deserialization from the ledger that is just part of the read asset transaction, where again it's not where it belongs. So we are going to be updating these or changing these to be much simpler, more readable code with Hypernate. Before we do that, I also want to show you the testing part. So I'll be demonstrating that the thing actually still works by unit tests instead of deploying to a test network or anything like that. But within the Hypernate samples repository, there is an infrastructure built on another labs project, Fablo, where you can actually also deploy the samples and try them on a local test network. So the asset test class is not super interesting. It just checks the basic behavior of the asset class, but the asset transfer test suite contains 19 methods where, if you look at the structure here, all of the different transactions are tested, both the happy path and the times when things don't go quite as well. For example, when an asset already exists and we want to create one, then we are supposed to throw an exception. So all of these are tested here. Another thing I want to mention right off the bat that I'm not going to be presenting on this specific meetup, but we are also using a small testing framework that's called TestUtil for now. You can see it in the imports here from Chaincode.TestUtil.contract testing. This just gives you kind of wrappers and more friendly, developer-friendly interfaces to test your smart contract. So to give you a simple example, in the create asset transaction, we can use this contract testing API to say what we expect to be on the ledger before we proceed to our act phase of the testing. So we can establish that we have an asset whose composite key should be constructed this way. So this is what the stub mock is going to return. And then that we have the within our ledger state. In this case, we are saying that asset one shouldn't exist. We can, of course, also say that this asset one should be available at that composite key. And then we can proceed to interacting with our unit under test, in this case, the contract itself. And then besides the usual assertions, we can use the contract testing objects assertions, for example, on the state, where we have these I guess, more readable APIs for whether an asset was read, how many times it was read, and in general, how many times we updated the ledger in general. There are similar APIs for how many times the read state operation was used on the stub, and you can also check things related to events. This is still a work in progress, so I will treat this it's treated as a black box in this demo. It's actually here in a jar file that is just a local dependency for now. And let me proceed then to applying Hypernate to this. Before I do that, I just want to show you that indeed in the initial state it's working. So Hypernate is going to we are going to check like as a regression test every time, or most of the times that it still works. So the first thing, of course, is to include Hypernate as a dependency. This is something I don't want to now mess with, so I'm just going to check out the next revision, and it shows up here. So this version, and of course also in our build scripts, we see Hypernate appearing as an implementation dependency. Once I have that, I can now start using the library. And the first thing you want to do is to replace the superclass of your contract class by HypernateContract. So this is what you want to implement. HypernateContract is, of course, also a contract interface, but it also does a couple more things. For example, it overrides the createContext method to give you a Hypernate context. And the Hypernate context is in turn what gives you a registry, and the registry you can use for your object level CRUD operations, which we are going to look at right now. So for example, let's start with the create asset transaction. Let's see how this would look if we were using Hypernate. So first thing I'll do is replace the context here with the more specific Hypernate context. And once I have that, I can, instead of getting the stub directly, I can now get the registry from this context. And on the registry, I have these, well, all of the usual read, update, create, delete operations that Attila was mentioning, and with the different semantics, must and try semantics. In this case, I want to use must because my original logic says that if the asset already exists, then I want to throw an exception. I want it to fail. So the natural translation of this is to use must read. And for must create. So we are creating must create. And this is expecting an object now, not key value pair or anything like that. We are working with objects. So I'll have to create an asset object given these parameters. So I'll just use the constructor to do that. Asset ID. Hopefully I get some auto completion. Here we go. And then I can just pass, I can just pass this asset to the registry. That's almost it, except this transaction should return the created asset. So I'll also return it at the end. And this part here, I can eliminate because if must create is unable to create an asset because it already exists, then it shows an entity exists exception already. So I don't have to do any additional checking or handling of that. Now, one technicality I have to do before proceeding is to update in the text, the type of context that we are using, since that's going to be passed to the contract methods. So I'll just have to change this to the explicit HypernateContext. And now it's still not going to work for one reason. We forgot to do one more thing. If I look up at the problems here, I see that asset doesn't have a primary key annotation. Now this makes a lot of sense because the code that I just removed contained within it how should the composite key of an asset be assembled. It basically contains information what identifies an asset, how to generate the key where that asset is going to be written. It was hidden here in the put asset function, but I'm no longer using that. So in Hypernate, instead of doing that on the spot or anywhere else or writing that code yourself in the first place, you can put just an annotation on your entity class, primary key. Primary key takes a list of attribute info objects. So I'll just put 1 in this case for asset ID. You have to specify the name of the attribute that constitutes part of the key. In this case, it's a single attribute key. Another thing I can do to make this a bit nicer is to use field name constants from Lombok. And then I can use the little bit nicer static value here. And if I had more, I could include them here. Also, just a quick side note about Lombok, Hypernate plays really well with it. So if you are familiar with it, it works well for Chaincode development. Actually, Hypernate does rely on Lombok as well for a lot of things. It eliminates a lot of the boilerplate as well in the same vein as Hypernate does. So I will maybe be showing how you can also remove a lot of this stuff here that is just not useful to implement yourself necessarily. Now that we've done that, I can rerun the tests and they all pass. So it still works. Now let's look at something else. So we just, sorry, where are we? Asset transfer. We just eliminated all of the boilerplate code and we're left with 3 lines here. Let's also look at a read operation now. So this is also quite long because there is all the checking of, okay, I get this state. I have to check whether that's an empty string, because if it is, then the entity or the asset didn't exist. And then I have to try to deserialize it, which might also fail. And all of this code is just littering the business logic part here. Instead, I can use HypernateContext and once again, get the registry. And again, I want to use must read because I want to fail if it's impossible, if it doesn't exist. Now, must read takes a class as its first parameter so that Hypernate knows what to deserialize into. So I'm going to pass asset.class. And the next parameter is the variable list of the attributes that make up the key, the primary key. In this case, it's only asset ID. And this returns an asset. If it doesn't exist, it throws. So I can essentially just return the asset that must read gives me, and all of this can go. And we are left with this one line. If I run the test again, just to be sure, then I see that the test, okay, I'm always running all of the 19 tests, a bit wasteful, but within them are the read asset tests as well. Okay, I think we have time for one or two more. Before I jump any further, we can look, for example, at how it would look to delete an asset with Hypernate. Again, we don't have to check whether it exists. We don't have to deal with the stub manually. What we can do is, in this case, we create a temporary or like a partially instantiated asset object. Actually, before I do this, so I don't have to. Okay, asset right now doesn't even have a constructor that allows us to do this, which is a bit unfortunate. So I could pass nulls or whatever, it could also work. But this is a good time to show you that I can actually have a much nicer and simpler interface to deal with the asset class itself by using Lombok. So I'm just going to apply the value and the builder annotations on it. So what value does is it automatically makes it final and makes every field private and final as well. And it also generates the getters and the no argument constructors and the other constructors as well. Of course, also the equals and hash code. And I'm only going to leave the two-string implementation as that seems to be custom. And for technical reasons, I also have to add checksumized to this. And now I can go back to here and I'm going to create a partial asset here using the builder that's provided by Lombok. So this is why I added it. I'm just going to set the ID of it to whatever the transaction receives, and I'm going to build it without setting any other attributes, as they are not necessary. When Hypernate must delete operation receive the asset, it's going to look, of course, for the primary keys or for the key only, which can be built from asset ID. And actually, this is it. So again, no need for the checks. And this is how a delete operation looks. I can once again check the tests. Maybe another interesting thing to look at is the asset exist function. This is mainly used as a utility, but it is meant to be a publicly accessible transaction. So what I can do here is again use HypernateContext. And for this operation, I don't treat it as an issue or an exceptional case if the asset doesn't actually exist. This is what it's for, to check that. So I'm going to use try read for an asset with this ID. And try read doesn't throw an exception if it doesn't, if the asset doesn't exist, but rather it just returns null. So to implement this function, I could just check, oops, I'm sorry, I can return that this is not null. And with this, I just implemented the asset exists check. All right, okay, I am now going to jump a bit ahead to a state where all of these operations have been updated, because I think you understand how it works now. So I'm going to check out this revision, and it's all the same, except there are some updates. You can see actually examples here. So for must update, I'm simply just again passing an updated version of the asset object. And that's actually all the operations. I also replaced the creations with try create for the init ledger, as I consider that to be a transaction that shouldn't fail if they already exist. It doesn't matter. It's not for that. All right. I think this was the part for the object-oriented API. And now we can move on a bit to the middleware part. So let me demonstrate this by adding an additional requirement to this function, to this transaction, and I'm going to explain from that why a throttling middleware, which we are going to be implementing here, is useful. Let's say that I have a requirement that for transferring an asset, it has to have an appraised value of at least something, let's say at least 100 imaginary units. One way of implementing this as a developer could be to just add the check here. So I could just say that if the old assets appraise value is less than 100, then I want to throw a Chaincode exception that can say that asset something's value is too low, something, let's complete it. So I'm going to put the assets, actually I can use asset ID and the get appraise value to show the value in the exception. And this is going to work since at this point, if this exception is thrown, then the transaction is not actually going to pass through, and whatever we try to do here will be rolled back. We can also test that by just quickly copy pasting or creating a test for this case. There is already a case here when we are, so these are the asset transfer tests. The transfer asset tests. And here is the one where we are checking whether we throw an exception if the asset is not found. I will just duplicate this and say that it should throw when asset value is low. And then let's actually make it too low. Let's say 50. And now we can see how it looks when I'm using this test utils library. So everything else can stay the same, but I want the asset to be existent in the ledger. So I'll just use the simple set call here. And yep, I catch some exception. I expect to catch an exception. And then we can make our assertions. I'm not going to check reads here, but my expectation is that since this transaction should have failed, there shouldn't have been any writes or attempts to write to the ledger via the stub. However, if I run the test now, I'll see that this is actually not the case. So never wanted, but once invoked here. Of course, the reason is that here we already have a must update call before that is going to get to the stub. And even though we fail here by throwing an exception, that's still going to happen. It's not such a problem per se, but we can say that it's pretty useless communication with the peer. So instead of doing this, we can, dealing with this issue could be done in place here. Of course, we could just refactor the code now to do it in a better order. You can also imagine that there is a bunch of things happening here. Or maybe there are multiple transactions within this context done, and it's hard to follow. Or you can say that it has to be done this way for whatever reason, or we just want to add a safety net. But we can still deal with this issue without forcing ourselves to change how this logic is performed, and without littering the logic here by adding a middleware. What our middleware is going to do is not send all of the put state calls immediately to stub, but rather wait until we know that the transaction is going to succeed. And then in a batch operation, we are going to send all the put states to the stub implement, to the actual final Fabric stub, or the next stub in the chain, I should say. This shouldn't change any of our of the existing semantics, but it will stop this useless put state from actually getting to the stub. So what I'm going to do is create a new class here that's going to be my middleware. I'll say throttling middleware. And to implement the middleware, you need to extend the stub middleware. Just extends the stub middleware class. And you can leave it as is, then it doesn't do anything. There are default implementations. But if you want to hook into something happening, such as a put state or get state operation, then you'll have to override those methods, basically all those stub methods. So I am going to now override put state. I could also, to be complete, I should also maybe update put string state and so on. For now, let's just focus on put state. And let me just quickly rename these to their appropriate values. And instead of using the default implementation super put state, which would just, in this case, it would just, if this was the only middleware in the chain, then it would immediately do what a normal put state would have done. If we have multiple middlewares, if you remember Attila's diagram, then it would just go to the next one. But instead of this, exactly what I want is to stop here and not actually proceed with this write, but rather I'm going to save it in memory, basically, into my local mapping, where I have a, let's call it this. Let it be a hash map. And I'm just going to store these writes here for now. So I'll just put it into the writes instead of using put state. And then, of course, I need to at some point actually make the writes. So what I'll do for this is to override the onTransaction and event handler. Hypernate has a built-in notification mechanism. One of those notifications matches the one that the contract has originally, the after transaction, I think it's called, hook. And Hypernate takes care of sending out these transaction and notifications to all the middlewares in the chain. So if I override what happens when I receive this one, then it should just work. And in this case, we don't need to call any super function, but rather I want to apply these writes. So I'm going to say writes for each, and for all of them, I'm just going to call supers put state with all of these values, key value pairs. Now that we have this middleware, that's all it is. We need to add it to the contract. That again is done by an annotation. So I'll put middleware info. And it takes just a list of classes, which it will instantiate for me. So I just need to say throttling middleware.class. I could specify more. Actually, in a later revision, you will see that I defined 2 of them. And that's it. One more thing that I don't want to do now on screen, but rather I will make a jump, is that since for this testing to work properly, since we are calling the methods on the contract and there is no actual SDK, nobody's going to call the after transaction event. So what we would have to do is, actually I can do it on this. Actually, for this function, I don't have to do it anyway, since something will be thrown. So I can actually try this already right now, whether it will work. And I see that the test that failed previously now passes because of this middleware, because now we are not actually letting any writes pass through. But in reality, let me just show you another one here where this is now going to fail in turn because we're not sending that notification because there is nobody to send it. So what we would have to do is to add after transaction, and then now we do what should happen in a deployed scenario, and now the test will still pass. So whatever was working before works now. I would have to do this at all of these places. I'm not going to do that on screen now. Rather, I will jump to the revision where both of these things have been added. And I will also show that there is another middleware defined in this final state that's just called logging middleware. All this does is it hooks into get state and put state and logs a warning message. Warning so that we can more easily see it in the logs, but you can do whatever you want here. So this is just based on the same logic, another middleware, and it's chained in with this annotation. Now I'm going to rerun the test so we can see that it still works. And we can also see the highlighted lines that are the warning messages. Those come from that middleware. Hypernate also on the default configuration, I could set it up in the log config, but it sends a lot of debug messages based on how it's composing the keys and what states methods are called and so on. You don't have to have those. And then you could, in theory, improve your logging, what you don't want to necessarily do within in the business logic part using a middleware. There is also a lot of other things you can do with the middleware. A student of mine, a bachelor student, implemented inversion programming with a middleware where he built a voter component essentially into this that stops the writes again. And in a certain event, it checks all the evaluations of a function call from different implementations, does a majority vote on them, and then proceeds based on that. So it's I think a funny example. And before I finish, just one more thing that I wanted to show you that I missed is what it would look like if you have multiple attributes that you want to treat as your key. Let's say that instead of the simple string asset ID, I want to have the owner as the primary key. I'm just going to move it here so we can see. And I also want to have instead of the asset ID one, I'm going to call it asset index. It's going to mean the index of the asset of that specific owner. And I'll say this is an integer. So now an asset is uniquely identified by its owner and the index of the assets that owner has. And then in this case, I could update my primary key to be this array of the owner and another attribute info of the asset index. And since this is an integer, this is where the mapping functionality comes in. If I were to leave this as is, then the default implementation of mapping the value of this attribute to a string, since the key parts will have to be strings in the end, will be done by just calling toString on it. So for an integer, that's just going to convert it to the natural integer representation. The problem with that, of course, is that the values are not going to be written to the ledger in the order you would expect necessarily, but rather in lexicographical order, the ordering of 1, 1 and 1, 1, 1 and so on. So instead, we can deal with this by adding a mapper, which just takes a class definition. For example, a class such as integer 0 pedder. And what this one does is it converts it to a string in such a way that it pads it with a bunch of zeros, so the lexicographical ordering is going to be correct. We also have other built-in padders, mappers in Hypernate, one for longs. There are also ones that reverse the order if you want to normally iterate backwards. And of course, you can also roll your own. So if you go to the definition here, then this is just, you need to implement the attribute mapper class. And actually, that's just a function of object to string. So you just have to supply a function like that, and then you can roll your own. I am going to undo all of this stuff because it would need a lot of other changes in the code to work. All right. Okay, I think that was all for today from my part. I would like to pass it back to Attila or Imre if you have anything else to add. And of course, this is a good time to stop or ask me if you have any questions.
Thank you, Bertalan. I still have 1 or 2 slides to show you. Then I think we can proceed to the Q&A part, and the floor will be open to anyone. Let me just share my screen again. Hopefully you will see the live demonstration slide. So I will skip this slide. So we have a bunch of new features coming and have in mind, but we would very much be interested in your feedback, what you found as pain points throughout your development journey for Chaincode, and what could alleviate your issues as a Chaincode developer. So let us know any idea you might have. But I think more importantly, that what we have to emphasize is Bertalan showed a lot of cool features about Hypernate, but more importantly, he also showed some magical methodology to actually migrate your code to Hypernate while not touching a single test case, essentially. So you could step by step migrate your solution to Hypernate if you write your tests in a kind of platform agnostic way, and we will also open source the library to help you do that exactly. So this was one point, that there were a lot more behind the scenes that might seem at first. And the second point is that such a modular solution of Hypernate and the separation of different independent concepts like tracing information, logging information, caching, throttling on the Chaincode tab level, and working with annotations and being declarative instead of imperative in programming, it opens up a lot of pathways. Bertalan already mentioned, for example, inversion programming, which is kind of a fun way of implementing the same difficult algorithm with multiple teams in multiple algorithms, but at the end you can vote about the results, whether they were right or not. So if there are any non-trivial algorithms that you cannot fully test because it works on numbers, and the complete testing of the entire integer state space is of course out of question. So at that case, some critical scenarios, this is a trident to pattern, which is more costly, but if you need exact, complete, and correct solutions, then of course you have to sacrifice some costs for trustworthiness. And another part is, for example, that all these aspects, for example, caching is a fine example of this. If we are serious about writing caching, then that essentially is a state machine implementation of the cache entries. And as such, state machines have a lot of formal validations assigned to them. And for example, using the Java modeling language and some supporting implementations, Bertalan also did a lot of annotations that can be checked formally with mathematical precision during development time, but also can be enforced during runtime. So this whole separation of concerns opens up a lot of pathways for us in the academia to test such approaches, critical system development approaches on smart contracts, but also for you to actually apply these approaches in a minimally intrusive way. Imre, would you like to add something on this note?
Not really. You stole my limelight a bit, but yes, indeed. So on the academic side, the reason for creating Hypernate was that Hyperledger Fabric is in a bit of a curious position due to its more classic operational model, and indeed for the ability of writing Java chain code. It should be theoretically much easier to create methods of formal validation and verification for smart contracts, chain code, at least in comparison to the whole Solidity and EVM world. But to be able to do that, to utilize all the Java tooling that we have, either at design time checks or runtime checks, we were actually needing something like Hypernate. So yes, it was born out of our frustration in actual development on the one hand, but on the other hand, for the scenarios where you absolutely have to be sure that your chain code does what it is intended to do, for those cases, to use the approaches that can come up, we do need Hypernate, period. And the academic research that mostly Bertalan is doing is focusing on this. So from an academic point of view, this whole thing is actually, quote, just a prerequisite, unquote. And I think that's that.
I still have one note to add. If you are thinking about along the line that, I mean, Fabric X is coming, it's here, chain codes will be deprecated. No, chain codes will be called something else, but your business logic and the endorsement for that business logic will remain the same requirement for Fabric. So Hypernate will kind of give you a higher abstraction that if Hypernate or when Hypernate will support the Fabric X programming model, then you can easily migrate your chain code to Fabric X smart contracts, let's call them. So having higher abstraction under your business logic makes your code more portable, even between DLT solutions, or even just plug and play your CRUD model into some non-blockchain solution. So reusability is king.
And let's step this awful academic slide, shall we?
Yes. And now is the time
Okay.
for questions.
Yeah. So thank you all for being here. We do have 10 minutes. So if anybody has any feedback, question, then we would appreciate that. You can write it in the chat, or we were told you can even switch on your mic and video and simply ask it. Fair warning, the thing is going to YouTube. So if there's nothing, then thank you for being here and listening to us. Discord is up on the screen too. You have our GitHub there. The whole recording will be available on YouTube. And could you please post those links on chat? Sure, we can. We are just doing that. And if you want to begin to tinker with it, this is an open project. We would be more than happy to have users, contributors, testers, whatever fits your interests. Okay. Attila, do you want to add anything else?
No, I think you said it all. So Hypernate became a community project, so let's work on it together. If you have ideas, feedback, hit us up and let's talk about it. And I think, Bertalan, on that note, you can stop the recording as host. And thank you for being here today, everyone.
So thank you all, and hopefully see you soon in the usual community.